Good day, everyone, and welcome to Physics and Mathematics Lovers. Today, we shall look at a topic on physics that says scalar and vector quantities. But before we look at the background knowledge of this topic, do not forget to share this video as you are watching and comment, write any question you want to ask us. Also, subscribe to our YouTube channel where we have a lot of videos that will enlighten you. All right, let's look at scalar and vector quantities. When we talk about scalar quantities are those quantities in physics that has only magnitude but no direction. We are talking about magnitude. We are actually talking about the scale value of that particular quantity. For example, when I have mass. Now, mass can only be measured, but we don't have direction for mass. We can only use scale to measure mass. Now, if we have mass, we also have what? Length. Length is example. Time is example of scalar quantity. All these quantities are only talking about what a particular value, which is what they have. But there is no direction to tell us where or at which angle is what it measured. Now, we also look at temperature. Temperature only has a scale value, which we use what? Either thermometer. We use thermometer to what? To measure in centigrade or Kelvin. So all these ones are just talking about what? Magnitude, but no direction. That is what? Scalar quantity. And when we want to add them, you just add them by what? Simple addition and what? Subtraction. That is for what? Scalar. Now let us look at vectors or vector quantities. When we're talking about vector quantities in physics, they are those quantities that have both magnitude and what? Direction. Yes. Example of such quantity is what? Force. We have a force. Force is example of what? Scalar. Then velocity. Velocity. It has what? Both magnitude and what? Direction. Then we also have what? Weight. The weight of the body. Then we have what? Acceleration. Acceleration is a what? Vector what? Quantity. We also have what? Field intensity. Electric field intensity. Electric field what? Intensity is example. And we also have what? A lot of them. Now, when you look at this again, we also have a displacement. Displacement is an example of what? A vector quantity. And these vector quantities is represented by what? An arrow. So if I want to represent a vector is represented as what? It's represented by what? An arrow. So this represents vector. For example, vector A. This is an arrow showing you. And the arrowhead is the one that is telling us the direction of what? Of this what? Vector. So vector has what? Both direction and magnitude. Now when we talk about what? Displacement as a vector quantity. Yes, this displacement that we are talking about, it is a distance that is measured in a specified direction. If, for example, a car, let's say a car start moving from point A here, and this is north, it moves from here. This is your north, south, this is your what? West and what? East. If a car starts from here, it will move, and when you get to this place, it can decide to change direction or move toward to the east part of it. Now, and at the end of the day, it moves back to this side. If I want to measure the displacement of this car that is moving, so the displacement will have to be from here down to this place. So all these ones are distances. Here is a distance, this is a distance. But the displacement with which this object moves, this is the displacement moving from north down to this place. This is where the car is now. So this hypotenuse of this triangle, forming this triangle, it is the displacement. So the resultant here is what the displacement of what? The movement of this car. Now, for that of a scalar quantity, you can also add distance. Distance is also an example of what? Scalar quantities. Distance just has what? A value. For example, just what? Difference between 2 points on a plane. It's just what? Distance. While displacement is that particular distance in a specified direction. Look at it here. This is direction. And here to here. So this is our displacement. Now, from here, you can be able to differentiate between scalar and vector quantities. So in our next video, I am going to teach us vector additions, the basic rules and laws of what adding what vectors. And scalar addition is very simple. Just add. If I have time like what 5 seconds or 15 seconds as a scalar quantity, and another one I have another like 20. What I will just do, just add the two of them. Just say 15 plus what 20 equal to what 35 seconds. So this is just a simple addition. We just use simple arithmetic in adding what scalar quantity. So in our next video, we are going to look at what vector addition resolution. So I have been posting, solving, but video lectures have not been given in that. So I want you to share this video as you watch. Also extend the knowledge to others. God bless you as you do so.